discuss a very important topic. This topic is more or less not much important for computer science student, but for other branches like mechanical, civil, as well as electrical, electronics, and instrumentation. In fact, is important because you will find the application of this particular topic in your respective subjects. For example, for electronics guys, you will find this in your electromagnetic theory (EMT). In fact, the topic is important in terms of engineering maths also from gate perspective. The topic which I am talking about is vector calculus. You know what is the difference between a vector and a scalar? Vector basically has a magnitude as well as a direction, while a scalar only has magnitude. Only has magnitude, right? So we are not talking about scalars here. We will be talking about scalar field, but we will not talk about scalar quantity here, right? So vector we know is denoted by arrows basically. Let's say this is a vector denoted by something like this, right? And let's say there is another vector which is b vector. So we can have two types of vector operations. That is, number one, we call it dot product, or we also call it scalar product of two vectors. We also call it or scalar product of two vectors, right? It is something like a dot b. How we define it? It is nothing but magnitude of a into magnitude of b into cos theta into cos theta, right? So if you sometime want to find the angle between the two vectors, so theta can be written as a vector dot b vector upon modulus of a vector into modulus of b vector, right? How you find out the dot product? For example, I have a vector a1 I cap plus b1 j cap. This is, let's say, a vector, and there is a b vector b1 I cap plus b2. Sorry, this is a2, let's say, j cap. So what will be a dot b? A dot will be I. That means a1 b1. I into j will become 0 plus a2 b2. That will become your answer. Clear? Right? Similarly, we can also talk about cross product. Cross product. Cross product is a cross b, or you can say ab sine theta, right? So this is the cross product, right? Cross product basically you are curling this towards this. This is the theta angle. This is, let's say, a cross b. Now a cross b is very different from b cross a, because if I'm talking about b cross a, you are rotating. Let's say if I'm talking about b cross a, you are rotating the b vector in the direction of a vector. Here when talking about a cross b, you're rotating a vector towards the b vector. Getting my point? So they will be giving you equally opposite directions, because the direction is given by the thumb rule, right? If you point your fingers towards that thing, your thumb will give you the direction, and is perpendicular to both the plane of vector and the plane of movement. Is perpendicular. For example, if I want to find out a cross b in this case, the resultant direction, the resultant direction will be inside the plane, right? But here if you find out in this case A cross B, then the direction will be outside the plane, right? We represent cross as inside, dot as outside the plane. Clear? So these are basic operations on vector, and this is not what is required. We are talking about vector calculus, so we'll be talking about the calculus fundamental here. These are just basics which I wanted to discuss before we get into the actual types. Before we start anything, let us talk about something called as del operator. Represented by this del. Now, as the name suggests, del operator, it is an operator. What is an operator? For example, plus, multiply. These are all divide. These are all operators. Do they have individual meanings? What I mean to say is that means if I write plus, what does that mean? It does not mean anything. It looks like a doctor sign, isn't it? Unless and until I write something here and there. Now it is a meaning. You can get an answer. 4 plus 8 is 12. Right? So this is an operator. This is a operator which individually do not have any meaning. Same is the case with del. Del individually do not have any meaning unless and until it is applied to something. When it is applied to something, then only it will have a meaning. So we say del individually do not have any meaning, right? Clear? Okay, so what I'm telling is del individually do not have any meaning, right? Unless and until it is operated by some or the other scalar or a vector quantity, it will not make any meaning, right? Now what is del mathematically? So if you say mathematically, del represents nothing but a value in terms of, it is mathematically given as d del by del x of I cap plus del by del y of j cap plus del by del z. This is z, let me make it more clear, of k cap. This is basically the mathematics or mathematically vector differential operator del. Clear? Right? Now there are certain things we need to understand here. Number one, we'll understand the concept of gradient. We'll understand the concept of gradient. Now what is gradient? Let us understand this. Let's say there is a scalar field f, a scalar field small f in terms of x, y, or z, or whatever variable it is. So grade of phi, or sorry, grade of f, not grade of phi, grade of f is represented by this del operator. Del of grade of f is mathematically given as del f by del x of I cap plus del f by del y of j cap plus del f by del z of k cap. This is basically gradient of, so we have defined what is gradient of a scalar field f, right? Now we have found one important result, that this was a scalar field. What is gradient of this? It's a vector function, right? Now what I'm trying to say is, important thing is, gradient of a scalar will give you a vector. Remember this is important, right? Correct? Okay. We'll solve questions on this. First, let us understand a couple of more things. Second, we'll understand is something called as directional derivative. Directional derivative. Now, what is directional derivative? Before going to that particular area, we have to understand what was gradient. Now, if you see gradient, gradient is nothing. It is the vector normal to the scalar f. What do I mean to say is, try to understand. When I was talking about gradient, let's say if f x comma y comma z was a any surface, it is let f comma y is a surface, right? Then del of f, or sorry, you can say grade of f is a vector normal to the surface f. Clear? Now, what is, and if you talk about the magnitude, is with a magnitude, you can say with a magnitude equal to the rate of change of f along the normal. Now let me explain you in a bit detail what I am trying to say. Let us say this is a surface, right? You are talking about this point. You want the gradient at this particular point, this is x comma y comma z. So it is nothing but a vector which is in the normal direction to this point. This is your surface f, basically. Clear? This vector is going to be grade of f. Am I making sense to you? Grade of f is nothing but the vector in the normal direction, right? Now, coming to what is directional derivative. Supposedly this is this surface, right? This surface is basically, let's say, representing, the surface is basically representing, let's say, source of electromagnetic waves. You know, this is a source which is giving you electromagnetic waves, right? Or maybe some radiations or anything which you can assume on that particular platform, right? Now you have to understand this thing conceptually. What is this trying to say, right? Now I said that this is a point where you want the effect in the normal direction, so you will find out grade of phi. But it is not necessary that you will only find the effect in the normal direction. You may say, sir, I want an effect of this point of the source in the direction. So what is this? How will you find this? So this is nothing but the directional derivative. Getting my point? Let's say this is a vector. Maybe a r vector. Maybe a r vector. So how will you find? And this angle is making is, let's say, theta. Right? This angle which is making with the normal is the theta. So what I'll say is directional derivative. Directional derivative, normally called as dd, of f is equal to grade of f dot product with r vector. Grade of f dot product with r vector. Clear? Right? So We'll understand this with a couple of examples. Let us say a question is given to you. Find the unit normal to the surface. Let's say x y cube z square is equals to 4 at point -1 -1 2 -1 -1, right? Number one thing is this point should satisfy this plane. Don't say ki this point is away from this surface, that will become difficult. Now you have to find unit normal vector. So unit normal is nothing but the gradient. Very good. You just want to find out the gradient. So let us say my function f is nothing but x comma y comma z. The function f is nothing but xy cube z square minus 4 is equal to 0, right? So you want grade of 5 f, which is nothing but the normal vector. So that will be nothing but del f by del x I cap plus del f by del y j cap plus del f by del z k cap, right? So this will be very simply, you can say that it will be nothing but, first with respect to x it will become how much, y cube z square I cap, plus with respect to y it will become 3xy square z square j cap, plus with respect to z it will become 2xy cube z k cap. Now at, you want grade of f at point -1 -1 2. So if you solve it, it will become minus 4i minus 12j plus 4k. Now this is the vector, but what do you want? You want the unit vector. So unit vector of vector a is nothing but vector a divided by modulus of that vector, right? So similarly what you will say is nothing but modulus of this. This is the unit vector. So it is nothing but minus 4i minus 12j plus 4k divided by modulus is nothing but 4 square plus 12 square plus 4 square. So it is very simply, you can say minus 1 by under root 11, you can take common, is I plus 3j minus k. That's your unit vector, right? And this is basically the maximum value of the directional derivative also. Can you tell me why? Because if you are finding out the directional derivative, it will maximum in the normal direction only. Getting your point? So grade of phi is also equal to maximum value of directional derivative. Directional derivative. Clear? Keep this as a note. Important. Quite important. Right? Let us solve one more question. Find the dd, I mean to say directional derivative, of f x comma y comma z is equals to xy square plus yz cube at the point 2 comma minus 1 comma 1 in the direction of vector I plus 2j plus 2k. Now this is a very typical question of finding out a directional derivative. As I told you earlier also, we want the vector effect in the direction, as I told you, We want, let's say this is the unit vector which was grade of f. You want it in some direction which is given to you, right? At this point 2 comma minus 1 comma 1, you want that effect, right? So how will you find? First we have to find out the gradient, right? So grade of f will be nothing but del f by del x I cap plus del f by del y j cap plus del f by del z k cap. So let us find it out. It will be nothing but with respect to x, if you solve it, it will become y square I cap plus with respect to y it will become 2xy plus z cube j cap plus with respect to z it will become 3yz square k cap. Now you find out grade f at point 2 minus 1 and 1. It will be nothing but I plus it will become, so it will not be plus, it will be in fact minus. So it will be minus 3j minus 3k, right? This is the gradient of I, right? Now this is the normal vector basically. Now you want directional derivative. You want directional derivative in r direction, and r is what? I plus j plus 2k. I plus, sorry, 2j plus 2k, right? So what we will do? Dot product, right? So that is nothing but directional derivative is grade phi dot product with r vector. So grade phi is I minus 3j minus 3k dot product with I plus 2j plus 2k upon, this is basically unit vector, right? Divided by under root of 1 square plus 2 square plus 3 square, right? So this will be nothing but if I multiply 1 into 1 minus 3 into 2 dot product, you know how to do, right? It will be minus 6 and minus 3 into 2 will become minus 6 under root of 9. Sorry, this will be 9 plus 4, 13 plus 1 root 14. Sorry, this will be 2 square only. So it is 9. So this will be nothing but minus 11 by 3. That will become your answer. Now this was a crucial point which we missed earlier also. What I said was that the directional derivative is basically grade phi into unit vector, not only vector, but you can always say it is unit vector r direction. Clear, right? So this is about gradient and directional derivative. There are two more terms associated with this vector calculus. Number one, or the third basically, after gradient directional derivative, we'll talk about divergence. Now those were the two things which were applicable to scalar fields. Divergence is a function, or divergence is something which is used for vectors. We normally call it divergence of f, is denoted by del dot f, right? Is nothing but for a function, for a vector f, there f was a scalar, I was denoting with a small. For a vector f which is represented by, let's say, ai plus bj plus ck, right? Then divergence of f, then divergence of f is nothing but, you know, del operator, del by del x of I cap plus del by del x, sorry, del by del y of j cap plus del by del z of k cap into dot product with a I cap plus b j cap plus c k cap. So if you dot product, it will become what? Del by del x of a plus del b by del y plus del c by del z. Will it remain a vector? No. But f was a vector? Yes. So divergence of f is going to give me a scalar. Again, point to be noted. Point to be noted says divergence of a vector gives scalar. Clear? So it is very clear and crude which we have to understand. Right? One important result which we can understand. Again, you can say a note. If divergence of, let's say, a field phi, or not phi, let us take f, is 0, that means the dot product with the del operator with this vector is 0. If the dot product is 0, that means there is nothing in line. Getting what I'm trying to say? Dot product means I, j, j, k, k. Then only you get the dot product. And if it is 0, then I into I, j into j, k into k, all are 0. That means this is a condition. Then the vector f is called as solenoidal. It is twisted, purely twisted. Many times get have asked questions on this, right? Divergence of f is 0. F is a solenoidal vector. Clear? Right? Last term we will define here is called as curl of a vector. Curl is basically again defined by cross product with del. Right? Again, let us say f. This is curl f. F is nothing but, let's say, ai plus bj plus ck. It's a vector. So curl of f is nothing but ijk del by del x del by del y del by del z. Right? And divided by a, b and c. Not divided, but the third row would be a, b and right. So this is how you can find out the. Now again, if I say that curl of f is 0, then not. If curl of f is 0, then vector f is irrotational. You cannot rotate it. Curl is 0. That means if you curl is basically what I told you. Cross products are what? A vector cross product with b vector means what? A vector is turning towards b. A vector is turning towards b. So if it is 0, that means there is no turn available. There is no rotation which is available. Correct? So you have to be very careful with these things. Okay. One more thing. What will be, f was a vector? F is a vector. When I apply curl to this, right? Curl of f, or you can say curl of f. What did it give? Vector or a scalar? This will give you what? Vector or a scalar? It will be a vector only, I, j, k, cap. Yes, so it will give you a vector. Clear my point? Del operator on this curl, if you'll find, so it will give you a vector. So curl, not curl of a vector gives vector only, while divergence of a vector gives scalar. Important points. Clear? So these are certain areas which we need to understand, right? We have to solve questions based on this particular thing, so it becomes very easy and understandable for us also to get the questions, right? We'll have one question. We'll take one question on divergence so that it becomes very easy for us to understand how to solve the questions, right? Let us take find the divergence of the vector. Right, let's say at point 1 comma 1 comma 1. So it's very simple. You want to just say it is nothing but divergence of f is given as del of e, that is 2xy upon del x, plus del of 2y upon del y, plus del of 3xy square z upon del z. So with respect to x, if you do it will become 2y. With respect to y, it will become 2. With respect to z, it will become 3xy square. And if you want to do divergence of f at this point 1 1 1, it will become 2 plus 2 plus 3. So it comes out to be 7. Very simply you can get the answer on this particular area. Clear? Then sometimes you will find questions like, a vector is given to you and it is said that the vector field is irrotational and some ABC value ijk component is missing. So if it is irrotational, that means the curl of this should be 0. And if it is solenoidal, then we can always say divergence is 0. Clear? So this is how sometimes question can be asked on these things. So 4, fundamentally you have to understand what is gradient. Number 2, what is directional derivative, maximum value of directional derivative. Third, you have to understand divergence, which is del dot f. Fourth, the curl. If you understand these 3-4 things, maximum the questions you can easily solve on vector calculus. Right? There can be a whole infinite unit of vector calculus. We can go into infinite details and we can have a day-long session on this. But from gate perspective, this is sufficient and important for us. Thank you.